Okay, once more, we're going to finish up our discussion, our lesson on binomial distributions. And, all right, my right pen here. So, let's present the following example. So, we're going to focus on mean and standard deviation, and I'm going to give you another demonstration of how the theoretical mean and standard deviation match up with an experimental mean in standard deviation. So I'm going to have 20 events. We had 4 events occurring before, the 4 smoke detectors. And I'm going to say each of these events has a 0.6 probability of success. And again, there's only 2 possibilities, success or failure. Now, I want to talk about what does success mean and what does failure mean? Well, success doesn't always mean something good, and failure doesn't always mean something bad. Success is just, what are we looking for? We're going to see in the example, I made this a simple example, drawing marbles from a bag, and I said, well, we're going to define, the marbles are blue and red. I have to have only 2 colors, because otherwise it wouldn't be a binomial experiment. So, I defined a blue marble as success and a red marble as failure. Why? That's just, blue marbles are what we're looking for. Nothing, there's intrinsically anything good or bad about blue or red. Just, I like blue better than red, so that's what I'm going with. And they're all independent, which means, if we're drawing marbles from a bag, I'm assuming the one draw has nothing to do with the next draw. And again, we're drawing with replacement here. So let's see, before we even go into that, if I continue to draw sets of 20 marbles, so draw sets of 20 marbles. That's the 20 we have up here. Okay, and let x, big X is a random variable, be the number of blue. So I want to find the mean and the standard deviation of x. Now, 20 marbles, 20 draws, 20 experiments, times 0.6 probability of being blue. Well, I would expect 12 out of every 20 marbles to be blue. And I would expect the other 8 to be red. Okay, now what about the standard deviation? Well, the standard deviation, n times p times 1 minus p and that's going to be about 2.19. I'll say 2.2. Get rid of this thing here. So I would expect a mean of 12 and a standard deviation of 2.2, meaning that if x is the number of blue marbles, I would expect x to have a mean of 12 and a standard deviation of 2.2. Let's go to the demonstration and see how this actually manifests itself. Okay, so here I have a marble bag, and I can open this marble bag just to show you. At least I think I can. All right, well, take my word for it. There's 6 blue marbles and 4 red marbles inside here. Now, what I can do, I can take a sample of 20 marble draws. So I can draw 20 marbles at a time. And so if we go ahead and do that, okay, so here we go. We have blue, 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 red, red, red. 6 of one and 4 of the other. Okay, now what we can do here is I can take a sample of 20 marbles. So if we go ahead and do that, okay, you can see the results in this column over here. So I sampled 20 marbles from this bag. I put the marbles back each time. I have 11 blue and 9 red. Here I have 14 blue and only 6 red. Whoa, this was an anomaly here. Despite the fact that I have a blue majority in this bag, I selected only 7 out of 20 to be blue. And we continue doing this many, many times, and that's what we're going to do. So rather than repeating this one at a time, let's do this many times. And I think we're doing 100. If I'm not mistaken. Yeah. So here's what we're doing here. This is 100. Now, we're taking a sample of 20 marbles. We're taking 100 samples of 20 marbles each. And then we're recording each time how many of those 20 marbles are blue. The first time we got 14, 14, 10, 15, 12. You can see we're building a little histogram here to the side. I'm going to move it just a little bit. You can see the histogram is roughly centered around 12, which we would expect, because on average, since 60% of the marbles are blue, we should get 12 out of 20. Let's do this some more times, and instead of 100, let's do 500. Right. Well, it's going to take some time. Oh, maybe not. It's getting a little fussy on me. I probably shouldn't have done 500 marbles at a time. What's going to happen eventually is we're going to... Okay, there we go. I think we're done. Okay, so we have 500 marbles again, so you can see the histogram here. And as you would expect, well, look, most of the time we selected... Well, actually, no, we selected 11 more often than anything else. So, okay. Again, this is good. It's not a perfect representation, but we get a pretty nice L-shaped histogram around 12, and we should expect something like that. Now, let's take a look up here. This is what I want to focus attention on. So, of those many marbles, of those 500 samples, on average, we had 11.88 blues. Now, it's not exactly 12, because remember, in sampling, there's always some sampling error, but it's pretty close to 12, as we would expect. Now, you notice standard deviation, again, so the mean and standard deviation of these numbers, the number of blues out of 20, the mean and standard deviation of those numbers is 2.13864. Okay, let's go back to the calculations we did. 11.88 and 2.14. 11.88, so we got, so we got experimental, and, what was it, 2.14? I think it was 2.14. Yeah, 2.84, okay, so, there we go. So, geez, very close, 2.14, 2.2, and again, they're not exactly the same, but that's what these formulas give us. These formulas are predicting that if we did this experiment all this number of times, we should expect to get 11.88. Now, this shouldn't be too much of a surprise, because 12 is about 60% of 20. And standard deviation of a distribution, this 2.2 means we repeat this experiment over and over again, and we expect to get about 2.14, about 2.2 as a standard deviation. And again, if we take the standard deviation of our entire sample, we get 2.14. So I hope this was helpful in just showing you what binomial probabilities are, how we calculate different binomial probabilities, what the mean and standard deviation are, and what the heck do those mean and standard deviation, what do they actually mean.